In this video, I'm going to talk about reasoning and logic. And I went ahead and kind of prefaced that there's a secondary title here, and that's the idea that we're talking about mathematical arguments or looking at how to apply mathematics to arguments. So, this is just kind of introing the ideas that are used in both mathematical proofs and also in arguing that we see in everyday life. All right. There's two real basic tracks of reasoning. There's inductive reasoning and deductive reasoning. So inductive reasoning, that's the idea that we form conclusions based on examples or data or patterns. Data or patterns. And it makes sense when we have looked at statistics and talking about data, how it might allow us to form conclusions based on that. Deductive reasoning is the idea that we form conclusions based on facts, rules, laws, or definitions. Based, wow, that's a sad way to write that. Based on facts, rules, logic, or definitions. Now, this sounds very concrete. The idea that you're going to form a conclusion based solely on facts or rules or definitions or logic. So, this particular type of reasoning is much easier to do. And I'm going to label it that way because it is. It's an easier type of reasoning. It's taking factual information, things that we know to be true, and forming conclusions from that. Inductive reasoning is much harder and it requires a lot of parameters placed so that we know that our conclusions make sense. In fact, science is really based a lot on inductive reasoning. When you go and do experiments and then you form a conclusion, that is a form of inductive reasoning. Okay. So let me just give some examples and let's kind of decide whether it's inductive versus deductive reasoning. So let's say every time Bill watches his favorite football team on TV, they lose. So Bill stops watching his favorite team on TV. I'll just say stops watching them on TV anymore. Maybe he uses that as an excuse to go in person. Maybe he listens to them on some sort of radio broadcast of some sort. Okay, that's the idea. So, what type of reasoning is Bill using here? Well, this would be an example of deductive reasoning. I'm sorry, inductive reasoning. I apologize. Inductive reasoning. The reason is he is using his specific example of watching this team on TV, then they lose. Then maybe the next week he watched them again and they lose. Maybe they weren't broadcast the third week and then they finally won. And then the fourth week he watched them again on TV and they lost. So what's happening is his data, his examples are showing him that every time he watches them on TV, they are losing. Therefore, he concludes him watching them on TV is causing his team to lose. So this would be a form of inductive reasoning. He is using the constant example or data of him watching them and them losing to conclude that this must be the case, that he is causing his team to lose. So he can't watch them on TV anymore. All right. Let me do another example. And I'm going to leave a little space between the examples because I'm going to fill out some information based on some vocabulary in a second. Okay, so leave a little space there. In order to play sports, you need a B average. Oops, average. Jordan has a B average. Sorry, I don't know why I put the dash there. Jordan has a B average, so she concludes she can play sports. Wow, I'm having some writing trouble here. Sorry. She can play sports. There we go. Woo, I wrote it. Okay, so in this example, Jordan based her conclusion on a rule. The rule of probably whatever school she is attending is that in order to play sports, you have to have a B average. So this would be deductive reasoning. So she's basing it on a factual rule that is held true at her school. And therefore, in order for her to play sports, she has to have a B average. She does have a B average, so she concludes that she is able to play sports. Deductive reasoning. Okay. Now, in the structure of these kind of forms of logic and arguments are really two words that we kind of need to know. The first is premise. A premise means it's a statement used as a basis for reasoning. Oops. Basis for reasoning. So in this example here, the statement used for the basis of reasoning is that in order to play sports, you need a B average. So in this problem, the premise is in order to play sports, you need a B average. Double spelling average too. There we go. B average. In the previous example, the premise is every time Bill watches his favorite football team on TV, they lose. Oops. So I'm going to shorten that. So Bill watching his team on TV, they lose. That is the premise here. So in each case, the premise can be thought of as either a factual thing or example. In this case, the first one is data or examples. Bill watches his team on TV, then they keep losing. And it's factual that that happens. That is important. It's a true statement for Bill that when he watches his team on TV, they lose. And for the second one, the rule that in order to play sports, you need to be average, that premise is a rule that, again, we agree is probably going to be true. Could they possibly change? Yes. But in the case of these arguments, we're saying that these are factual things that are happening. These are true statements, these premises, and that's where they're drawing the conclusion. So our conclusion is the judgment, a judgment resulting from our reasoning. So we're using our reasoning here to form a judgment, and that is the conclusion. And in each case, our conclusion is the final sentence. So in this previous example, Jordan has a B average, so she concludes she can play sports. In the example before that, Bill decides he can't watch his team on TV anymore because that means it's not going to cause his team to lose, right? Like that's kind of the final part of that conclusion. But that was his conclusion. I can't watch them on TV anymore. I'm making them lose. All right. Conditional statements, and we kind of have seen it already. Conditional statements is a statement in the form of if then. So if something happens, then this will occur. Okay. So if is considered like the hypothesis. The if part is like our hypothesis. The then part is the conclusion from the hypothesis. Okay, so let me give an example of an if-then statement. Example, if a number is less than 3, then it is less than 8. That is an if-then statement. So the first premise being the minute a number is less than 3, it also makes the number less than 8. That is an if-then statement. So let's practice writing things in this format, in this conditional statement format. So let me give some instructions here. Let's write in the if-then format. Okay, so here, let me give some examples here for us to do that. All courses. Oh, here, now let me do this one. Every public beach must have a lifeguard. Okay, so let's pause for a second and think of this as an if-then statement. So we're looking at public beaches. That's our kind of starting point. The minute that is satisfied, it's supposed to follow then that we have a lifeguard. So that first part of the sentence does kind of imply an if, and the second part implies the then. So if a beach is public, then it has a lifeguard. And you can be more eloquent about how you word that. If you step onto a public beach, then there is a lifeguard present, right? You could say it like that, but that's the idea, is that if it's a beach and it's public, then we have a lifeguard on duty. All right, let's try another one. Let's say you will stay in good health. Oops, not supposed to have an L in there. In good health if you exercise every day. Every day. All right. So in this case, they kind of put the conditional part at the end, right? The idea is if you exercise every day, then you will have good health. So let's write it like that. If you exercise every day, we conclude then you will stay in good health. Oops. Notice I'm not commenting on the truth of these See that? I'm not really commenting on what happens if the first part's true. Because we know that there are cases where maybe it isn't. Okay. But we're not looking at that. What we're looking is what we conclude based on this statement. We're using this as if this is given to us as a premise and it happens to be true, what can we conclude from there? That is the idea of these if then formats. Okay. Let's say one more example here just to kind of drive it home. Students will not be admitted, will not be admitted after 5 p.m. Maybe it's a rule for an exam or something. Okay. So in this case, the idea is if you happen to be a student and you show up after, 5 p.m., you're not going to be admitted. So let's try to set that up as a clean condition for the if then statement. Okay, so let's say if you are a student, because really that's the basis of this. If you are a student, then you won't be admitted after 5 p.m. That's the simplistic, saying it simplistically. Simply, wow, there we go. So if you're a student, then you won't be admitted after 5 p.m. And there we go. There is some vocabulary for us to start the basis of understanding mathematical arguments.